Welcome to The Explainer. You know, it's something we all take for granted. Flipping a switch and the lights just come on. But what's really happening behind the scenes to make that possible? Today, we're pulling back the curtain on the massive, hidden batteries that are becoming the silent guardians of our entire electrical grid. Here's the thing. As we lean more and more on renewable energy like solar and wind, we hit a fundamental snag. These sources are amazing, but they're moody. They don't generate power 24/7, but we definitely need it around the clock. And that mismatch between when power is made and when we need it, well, that can create some serious instability. We're talking flickering lights at best and citywide blackouts at worst. So today, we're diving deep into the grid's essential shock absorber, the Battery Energy Storage System, or BESS for short. All right, so first up, let's really get into why these massive battery systems are no longer just some cool, futuristic idea, but an absolute necessity for our energy future. The core issue is actually pretty simple. The power we get from renewables doesn't always sync up with when we need it most. So on a really sunny, windy day, you might have way too much power flooding the grid, and that pushes the grid's frequency up. Too little power and the frequency drops. Think of that frequency like the grid's heartbeat. It has to stay in a super steady rhythm. If it gets too fast or too slow, the whole system gets sick. And that is exactly where a BESS steps in.
So, what exactly is this solution that's being rolled out all over the world to solve this huge problem?
And I want you to get this. These are not just concepts or lab experiments. We're talking about massive, real-world power plants. Just one major company in this space has already deployed systems that can handle over 700 megawatts. To give you an idea of what that means, that's enough juice to power over 500,000 homes, all at once.
At its core, a BESS is, well, it's pretty much exactly what it sounds like. I want you to imagine a colossal, rechargeable power bank, not for your phone, but for an entire city. It literally inhales electricity when there's too much of it, and then exhales it right back onto the grid when it's needed most.
So how does this whole thing tick? Well, a BESS really has three key parts working together. First, you've got the battery system itself. That's the heart of the operation, just rows and rows of incredibly powerful batteries. Then there's the converter system. Think of this as the universal translator, because batteries store DC power, but our grid runs on AC. This guy handles the back and forth. And finally, you have the control system. That is the brain, a supercomputer, making sure everything works perfectly, every single millisecond. Okay, so now we know what it is, but what can it actually do? Because this is where it gets really cool. A BESS is so much more than just a simple backup. Its speed and its flexibility are what make it a total game changer. It can perform a whole bunch of critical jobs that keep our grid stable and efficient. It truly is the Swiss Army knife of the modern energy grid. And here are just a few of its tools. It handles frequency regulation, keeping that grid heartbeat steady. It smooths out the choppy, unpredictable power coming from wind and solar farms. And it can even save everybody money through something called peak shaving. This is basically, you know how you charge your phone overnight when electricity is cheap? Imagine doing that, but for an entire city, to avoid using expensive power during peak hours. Now, what's really mind-blowing here isn't just what it does, but the speed at which it does it. For its most important job, frequency regulation, a BES can react in as little as 200 milliseconds. That is literally faster than you can blink. If the grid frequency spikes, it instantly starts charging to absorb that excess power. If the frequency dips, boom, it's discharging. It's this constant lightning-fast balancing act.
So, you might be wondering, how on earth does a person manage a beast like this in real time?
And the short answer is they don't, not manually anyway. The whole system is managed by this incredibly sophisticated control interface, usually called a SCADA HMI. You can just think of it as the ultimate dashboard, giving operators a complete live view of the entire plant's health and performance, all from one screen. This screen is their command center. From right here, operators can see all the crucial vitals at a glance: how much power is flowing in or out, the grid's frequency, the overall system health, and of course, how much juice is left in the battery. And probably the most critical number on that whole dashboard is this one, the state of charge, or SOC. Yep, it's exactly like the battery percentage on your smartphone, just, on an unbelievable scale. And keeping this number in that sweet spot is absolutely key to the battery's health and its readiness to act. Okay, but what happens when something isn't healthy? What happens when an alarm starts blaring in the middle of the night? Well, this is another brilliant part of the design. The BESS basically has its own built-in immune system. It's got layers of safety protocols and different fault levels that can automatically diagnose a problem and take action, often long before a human even needs to get involved.
And this table just shows you how intelligent that system is. A low-level Cat 1 fault, say a battery cell gets a little too cold, might just pop up a warning. But as the problem gets more serious, the system's response escalates. A Cat 3 fault could automatically stop the battery from charging to protect it. All the way up to a critical Cat 5 event, like if it loses communication with the grid, that triggers a full but safe shutdown of the entire system, all on its own.
So when you put it all together, these things really are the invisible guardians of our modern grid. They're working silently 24/7 in the background, balancing and stabilizing. They're what's making our transition to a renewable energy future not just a dream, but a practical reality. Which, of course, brings us to the big question. As this technology gets cheaper, more powerful, and spreads across the globe, are we looking at the final piece of the puzzle? Is this the key that will finally unlock a world powered entirely by clean, renewable energy? It's a fascinating thought, and the answer is going to shape the future of power for all of us. Thanks for joining us on The Explainer.